Hi everyone. In this video, we're going to continue section 5.1, and we're probably going to finish it in this video. And um, and actually, we'll go into section 5.2 as well. So the last part that we hadn't talked about section 5.1, I guess to refresh your memory, what we have done is we've talked about joint distributions and marginal distributions. So we learned how to verify that a joint distribution, joint probability distribution, is actually one for discrete and continuous situations. And then we've also worked with marginal probability distributions and how to find them from the joint probability distributions. And we also talked about properties like independence of two variables and how we can find that from joint probability distributions. And so now we're on to sort of the last thing that we're going to talk about. And again, this mirrors all the kind of stuff that we did in chapter 2 when talking about basic probabilities for just events. And now we're a bit more specific here. And that's conditional probability, or in this case, conditional distributions. Okay, and so here's a basic definition of a conditional distribution. If I have x and y are two random variables, they could be discrete or continuous. Okay, but they define it here as discrete, and a marginal probability distribution for x. So we've got a joint distribution, a joint PDF f of x and y, and then a marginal probability distribution function f of x, then for any value x for which the function is greater than 0, meaning positive probability, the conditional probability density function of y given x is this below. And that might be confusing. It's fine. Just remember, if we go back to conditional probability, we said the probability of A given B is equal to the probability of A and B over the probability of B. And so it's the same thing here. Okay, just replace, y with A with y, B with x. So probability of, or now the probability function of y given x is equal to A and B, the joint probability, which is now the joint probability distribution function, divided by the marginal probability of the conditioning variable. And so here that's x. And so now instead of just the probability of the conditioning variable, it's now the probability function. Okay, so that's all that's really changed here. So let me get rid of all this. Okay, and so it's defined over whatever y is defined over. That's its sort of support. And so, of course, if x and y are discrete, you replace the PDFs with the PMFs, and then you get the conditional probability mass function instead of density function. But that's the basic thing. It follows from the basic probability rules. And so it'll be helpful now if we see an example of what this might look like. And we're going to do it with continuous variables, just because it's probably easiest this way, and it involves a little bit of calculus. Okay, so if we have a joint PDF, which is the one that we've been working with, up here, 6/5 times x plus y squared. Okay, we have the joint PDF, and then we also found in our previous slides the marginal PDF, 6/5 x plus 2/5. Okay, now that we have those two things, we can find the conditional distribution of y given x. Okay, so I'm interested in finding f of y given x. And specifically, I'm actually given an x value. So I'm given that the value of x is going to be 0.8. Okay, and so I'm going to fill that information in with what we sort of know previously, and the definition of our conditional distribution function. And so we get the joint distribution over the marginal. So it's just the joint PDF divided by the marginal PDF. But wherever we see x, we're going to input or substitute 0.8 because we know that value. And so it's going to be on the top 6/5 of 0.8 plus y squared divided by 6/5 times 0.8 plus 2/5. Okay, so I did joint divided by marginal, and I substituted in 0.8. Now, we can, of course, you'll want to simplify this just for just for like subsequent steps. And so, let's see, 6/5 is 1.2 times 0.8. That's equal to 0.96. So we've got 0.96 plus 6/5 y squared divided by, I distributed the 6/5 and then multiplied together there, and then 6/5 times 0.8 plus 2/5, and 2/5 is 0.4. And so then we get 1.36. So it's 0.96 plus 6/5 y squared divided by 1.36. Okay, and so technically this is, well, I mean, all of this and this, they're both the conditional distributions. I'm just trying to simplify numbers. And you could even go further if you wanted to and divide 0.96 by 1.36 and 6/5. Okay, just to get no denominator left over. And so we'll do that. And 0.96 divided by 1.36 is 0.706. So I'm going to move down sort of a row and over to the left side. And so it's something like 0.706 plus 6/5 divided by 1.36 is 0.882. About y squared. Okay, so this, sort of our final thing, this is the conditional distribution of y given that x is equal to 0.8. Okay, most of the work I just did was simplifying. Now, I want you to find, so with that, now we have that distribution. This is defined over the interval y being between 0 and 1. Okay, and so what we need to do is we now need to find the probability that y is less than 0.5. So we need to find the probability that y is less than 0.5 given that x equals 0.8. Okay, so even though it's not there, even though x sort of isn't present anymore over here, there's still the implication that I only got to that distribution that I have circled, or that function, given that x was equal to 0.8. Okay, and so like any other distribution that we've worked with so far, really, to find the probability that y is less than or equal to 0.5, I'm going to take the integral of the conditional distribution from 0 to 0.5. okay, of 0.706 plus 0.882y squared. Okay, now I've run out of space, so I'm going to move up to the top of this slide. And so forgive me for my sort of sloppy writing. But we're going to move up here to the top of the example. Okay, I want to take the antiderivative, and of course this is all dy. And so the antiderivative is 0.706y plus 0.882 divided by 3y cubed. Okay, just doing antiderivative rules, and I evaluate this from 0.5 down to 0. Okay. Now, when I plug in 0.5, I have to do the calculations here on the fly. I didn't do them beforehand. So 0.706 times 0.5 is equal to 0.353. 0.353. And then we've got 0.882. Or rather, we should do 0.5 cubed. 0.5 cubed is 0.125 times 0.882 divided by 3, and then that is 0.037 about. It's really 0.0365, but we'll round to 0.037. So it's really 0.353 plus 0.037. Okay, and so when we add those together, we're going to get 0.39. 0.39, or 39%. And so then that is the answer to the question, what is the probability that y is less than 0.5 given that x is equal to 0.8? Okay, so that is conditional distributions. I don't have a your turn here just because we had lots of practice with this kind of thing before. And so hopefully this was fairly easy. Okay, thanks, and I'll see you next time.